In this video, let's talk about graphing a cosine function that has some stretches together. Now, if you're looking for some clarifications or examples of just graphing the parent function or just with some different types of translations instead, feel free to check out some of my other videos where I go over those concepts by themselves. For this example, we have f of x is equal to 1/2 times cosine of 3x. Now remember, it's important to know our formula for cosine functions. And if we can identify our a, b, c, and d values, that can help us understand how to graph this function better. So let's go ahead and rewrite our function so we can identify our a, b, c, and d values. So right off the bat, we have this value of 1/2 in front. That's going to be our a value. It's going to be 1/2 multiplied by cosine. But cosine of what? Well, we're going to have cosine of, it looks like we have a coefficient for x, and that's going to be this value of 3. So I'm going to go ahead and say this is going to be 3. That's our b value. And then we can go ahead and say this is 3 multiplied by x. And then it's going to be minus the c value. Now, we don't have anything over there for c, so it looks like it's going to be 0. And hopefully that makes sense, because if you go ahead and distribute, this 3 times x would just be the 3x that we have over here, and then 3 times nothing is just nothing. So that's why we don't have anything over there, and it makes sense because c is equal to 0. Let's go ahead and close those brackets there. And then for d, it doesn't look like we're adding or subtracting anything outside of those brackets, so it looks like d is just going to equal 0. And so for this particular cosine function, we have an a and a b value, but c and d are just both equal to 0, so we have no translations up and down or left or right. All right, moving on to vertical reflections. We're going to have a vertical reflection if the value of a is negative, but notice how the value of a is positive here, so we're not going to have any vertical reflections or flips across the x-axis. For the horizontal reflection, that depends on if b is negative. Notice how b here is a positive 3, so we're also not going to have any flips across the y-axis. For our amplitude, that's going to be the absolute value of whatever a is, so the absolute value of 1/2, that's equal to 1/2, and that's going to be our amplitude. Moving on to the period, this is the one that has a formula. So by default, the period formula is 2 pi over 1, which is really just 2 pi. But in this case, b is not equal to 1. So we're going to have 2/3 and we're going to divide it by the b value of 3. So this is going to be our period. It's 2/3 pi. So let's go ahead and write that here. Every 2/3 pi, this function is going to repeat itself. That's going to take one period right there. All right, for the midline, that's going to be dependent on the value of d. Looks like d is equal to 0, so the midline's not going to move. Remember, by default, the midline is going to be at y equals 0, that horizontal line. For the minimum and maximum y value for this function, we can find the minimum y value if we take that midline value and go ahead and take away the amplitude. So 0 minus 1/2 is going to be negative 1/2. That's as low as this function is going to go. And in terms of the maximum y value, we're just going to take that midline and add 1/2. So 0 plus 1/2 is going to be positive 1/2. Because the amplitude is equal to 1/2, you can think about this function as being vertically shrunk. Typically next, we want to find out our important x coordinates that are going to let us know kind of the 5 important points of graphing our cosine function, but I typically also like just filling in the parent function table first. And so remember, when we were graphing the parent cosine function, we always start up here at 1, then we go down to 0 every half a pi, then we go below to -1 at a whole pi, back to the x-axis, and then all the way back up to +1. So as long as we know this is generally what our parent function is going to look like, that can help us with this table. So we know some points for the parent function, but what about the function that we're dealing with here? Well, we're not moving anything left or right or up or down, which is kind of nice, but we are doing some stretching and shrinking here. So this value of 1/2 is going to let us know that we have a vertical compression, or we can think about that as a shrink. And then this b value of positive 3 is going to let us know that everything is going to be compressed horizontally. So let's go ahead and see if we can show what that looks like. So if this a value of 1/2 is going to affect how much up and down we're stretching or shrinking, and b represents the left and right, let's go ahead and use this b value of 3 so that we can write our new x coordinates here. Typically, our period for cosine functions are from 0 to 2 pi, but remember that for this particular function, we're going from 0 to 2 pi over 3, right? So our starting location is going to be the same, but our ending location is going to be at 2/3 pi instead. So this is going to be happening faster than normal, or instead of the whole period taking 2 pi to happen, the whole cycle is going to happen in 2/3 pi instead. If that's true, then we're starting at 0, ending at 2 pi over 3. Then halfway in between, we should be between 0 and 2/3 pi, which is really just 1/3 pi. So I'm going to put pi over 3 right in the middle. Then what's right in between 0 and pi over 3? Well, that's going to be pi over 6, right? Just because pi over 3 is the same thing as 2/6, and this is just 1/6, and this is 0/6, right? Now, what's halfway between pi over 3 and 2 pi over 3? Well, again, this is 2 pi over 6, this is 4 pi over 6, so you can think about this as 3 pi over 6, or half a pi. Just going to go ahead and write that in right here. So if we have these x values here, that's really what we're looking at for these 5 critical points. So we can just fill those in right now. Now what about these f of x or the y values? Well, we knew what the y values typically were for the parent function, but everything was going to be compressed here because of the a value of 1/2. So if you multiply things by 1/2, it gets smaller. So everything's going to be shrunk here or just compressed a little bit vertically. So for our new y values, we're just going to take each of our y values over here and just multiply those by 1/2, and that's going to get us our new y value. So multiply this 1 by 1/2, we're just going to end up with 1/2. 0 times 1/2 is still going to be 0. -1 times 1/2 is going to be -1/2. 0 times 1/2 is still 0, and 1 times 1/2 is 1/2. So essentially, how did we get from all of these x values to these new x values? Well, we had a horizontal compression, so you can think about multiplying all those original parent function x values, multiplying them by 1/3, or you can think about it as dividing each of them by 3. So you can say 0 divided by 3, half a pi divided by 3, pi divided by 3, 3 pi over 2 divided by 3, and 2 pi divided by 3. That's how we got those values. And for our new y values, we just took each of our original y values, or f of x values, and multiplied them by 1/2, or you can think about that as dividing by 2 here. So if you look at each of this y values, 1 divided by 2 is 1/2, 0 divided by 2 is still 0, -1 divided by 2 is -1/2, 0 divided by 2 is still 0, and half of 1 is just 1/2. So you can see that this 1/2 is that a value here, and then for our b value, just be careful and multiply it by the reciprocal, or 1/3, because we're dividing. All right, now that we have all our important points, let's go ahead and put this on the graph. Now feel free to space out your x and y axis however you would like to. I'm going to go ahead and say I'm going to break our x-axis into 6ths pi. So this is going to be 1/6, 2/6, 3/6, 4/6, 5/6, and 6/6. This is 7/6 and 8/6, but I just reduced down some of our fractions. This is -1/6, -2/6, -3/6, -4/6, -5/6, -6/6, or pi, and then -7/6 and -8/6, which is just -4/3. In terms of the y-axis, I'm going up by halves, so this is half, 1, 1.5, and 2. And going down in the negative y-axis, we have -1/2, -1, -1.5, and -2. Here's our midline of y equals 0. We're not going to move it at all because our d value was 0, so no vertical translations at all. As for our minimum y value, that's going to be down here at -1/2. And for our maximum y value, that's going to be up here at +1/2. This is just good to know, so we know where our function is going to be in between. All right, so our first point was 0, 1/2. That's going to be up here. Then we have pi over 6, 0. That's right on our midline. Then let's go down to pi over 3, -1/2. Then pi over 2, 0, back to the midline. And then finishing off this period, we're going to be at 2 pi over 3, 1/2, back to the same height as which we started. Let's just go ahead and now draw a smooth curve to show this graph. So this right here would be just one period of this function. If you wanted to continue this, we can go back to the midline, then down below, back to the midline, and back to the maximum. Moving over to the left side of this first period that we drew together, we can go ahead back to the midline, then down to the minimum, back to the midline, to the maximum, midline, minimum, midline, maximum. Continuing the pattern, it would look something like that on the right side. And this is what it would look like on the left side. Altogether here, you can see 4 periods for this particular cosine function. So that wraps up this particular practice problem where we had an a and a b value that were different than 1 as opposed to the parent function. However, c and d were both equal to 0, so we didn't have to deal with any of those types of transformations. If you're looking for a more complex example, feel free to check out some of my other videos where I combine all the different types of transformations together. If you found the video helpful, you can let me know in the comment section down below. You can also give the video a thumbs up, it helps a lot. You can also share this with a classmate or friend if they are also going to maybe find this helpful. And as always, keep it the great work that you're already doing, and I'll see you in the next one.